Good morning and a very warm welcome to everybody joining us for the first technical session of the International Engineering Education Symposium 2025. I'm Rajesh Kangsha and I have the honor and privilege of serving as session coordinator for this session. A special note from our inaugural session. One of our special guests, Hossain, was supposed to join us as our special guest. But due to some unfortunate timing, he couldn't join our symposium. He has sent his profuse apologies. As you already know, this symposium is on sustainability in engineering education. We've already heard the keynote speech from our Professor Dr. Mazharul Islam, a welcome speech from our Honorable VC Sir, Professor Dr. Muhammad Ashraful Islam, and a welcome speech from our chief guest, Professor Dr. Misbahuddin Ahmad. In this technical session, we will get to hear some amazing speakers and we'll get to see some very important presentation. Our session chair is Professor Dr. Ahmed Faris bin Ismail, who is a highly accomplished academic leader in engineering education and university management. As the Deputy Rector of Academic and Industrial Linkages at IIUM, he has spearheaded major initiatives to modernize academic programs and strengthen partnerships with industry. But driving innovation and elevating institutional impact, he holds a PhD in engineering from Rice University and is known for advancing cutting-edge curriculum models that emphasize both technical excellence, leadership, and development. Professor Faris has also contributed significantly to future studies and academic strategy, including serving as the co-chair of UNESCO Chair in Future Studies. Recognized for his visionary leadership and commitment to academic excellence, he continues to shape the future of higher education in Malaysia and beyond. So without further ado, I'd love nothing more to introduce our session chair, Professor Dr. Ahmed Faris bin Ismail, Deputy Rector of IIUM Gombak campus, to take over the session and chair this valuable session. Thank you very much.
Okay, thank you very much, Mr. Rajesh Kangsha Banik. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning in Bangladesh, but I think it's already afternoon here in Malaysia. So first of all, I guess I would like to thank the organizing committee for including me in this very, I would say that interesting and important symposium talking about sustainability in engineering education. I managed to follow half of the presentation by the keynote presentation by Professor Mazharul Islam, and indeed, I think that is the future of engineering education. Similarly, we are also in Malaysia are looking at this sustainability as one of the program learning outcomes, as well as now our Malaysian qualification agency also, they are looking at value-based education. So I think these are moving forward for our curriculum. Nevertheless, let me welcome all the participants to the first technical session of this International Engineering Education Symposium 2025. So in this session, we are going to listen to 4 presentations. Professor Muhammad Raisuddin Khan from IIUM Malaysia, and then Professor Salekul Islam from North South University, Bangladesh, Mr. Sakib Hossain Khan from University of Portsmouth, United Kingdom, as well as Professor Peter Hasle from Denmark, SDU Denmark. So as stated in the program, we will allocate 30 minutes for each presentation. So I would like maybe set the rule here. As the chairperson, maybe we will allow 20 to 25 minutes presentation. And then after that, we can have 5 to 10 minutes engagement session, some question and answer session with the participants. So our first presentation today will be delivered by Professor Dr. Raisuddin Khan from Department of Mechatronics Engineering at the International Islamic University, Malaysia, Kuala Lumpur. Brief introduction to the speaker. My colleague, Professor Raisuddin, received his Bachelor of Science degree in Mechanical Engineering from former Engineering College Rajshahi, Bangladesh, currently known as Rajshahi University of Engineering and Technology, in 1993. before receiving his master's and PhD degrees in mechanical engineering from BUET in 1988 and 1996, respectively. So currently, Professor Raisuddin is a professor at the Department of Mechatronics Engineering at IIUM. He has been serving the Department of Mechatronics Engineering for more than 20 years, with wide experience in designing and reviewing mechatronics engineering curricula of different universities in Malaysia and overseas. And he had been the coordinator of the Autonomous Systems and Robotic Research Unit at IIUM. He also has served as member of the Executive Committee of the IEEE Robotics and Automation Society Malaysia chapter for several terms. His research interest covers robotics, smart devices, vibration, and stress analysis of structures. He has received many awards from different national and international exhibitions for innovating different mechatronics products. And he has many publications, and he is a life fellow of IEB and BSME and a senior member of IEEE. So with that introduction, let me now invite Professor Raisuddin to deliver his presentation. Please, Prof. Raisuddin. You are muted. You are muted.
This is the common problem in.
Okay.
Thank you, Prof. Faris, for introducing me to this session. And Assalamualaikum warahmatullahi wabarakatuh to the session chair and all the audience today. So let me first try to share my slides and go to the presentation.
Are you sharing the presentation, Prof. Rais?
I'm trying. I don't know why clicks are not working. This is the common problem of online presentations. At the beginning, what's wrong?
Okay, coming. Yeah.
Okay, it's coming now. My presentation slide visible now?
Yeah,
Yes.
maybe you can put it in on the presentation. Click on the, yeah. All right. Yes. Okay, good.
Okay, so this is the presentation topic for. I forgot to put the presentation topic. Sustainability in engineering education. Okay, sustainability had been introduced since long with the SDG goals of the United Nations. So to go into my presentation today, let me first introduce to the presentation outline. Introduction, engineering contribution to sustainability, inclusion of sustainability in curriculum, specifically for IIUM. Course administration, how do we do lecture and case studies, sustainability in engineering design, sustainability in different universities, challenges and how to overcome the challenges, and conclusion. So the definition of sustainability, we know it very well. The sustainability development is development that meets the needs of present without compromising the ability of future generation to meet their own needs. And if you translate this sustainability, there are three core items in the sustainability: society, environment, and economy. So in short, to me, it is see far, not see near. That is sustainability. And as I'm trying to focus on sustainability in engineering, so let me put it back again, which is already introduced by Professor Mazharul, the sustainability emphasis by Engineering Accreditation Council. So if we look at this definition of engineering, so we had definition of engineering before by Ahmad and other societies, but this is the definition coming from Engineering Accreditation Council. If you go to end of the definition, the term sustainability is there, which I have highlighted blue. But the other terms which are there, they are also the component of sustainability: economic operation, health and safety, and life and property. So sustainability has become so important that they are talking about the sustainability again and again, even in the same paragraph. So when they came up with the program outcomes of 2024, they have come up with the program outcome 3 and 6, where the sustainabilities are there. In 3, design, development, and solution, the word sustainability is not there, but you can see net zero carbon as well as resources, cultural, societal, environmental considerations. So they are basically sustainability according to this SEE. And engineering in the world, again, you can see society, economy, sustainability. So they are coming in. And specifically, they put in their 2024 standard the IDP, Integrated Design Project. And inside the integrated designing project, sustainability consideration is there. So when you go to make a design on the integrated platform, and integrated design project has a lot of issues so far. We can see we started practicing even before this IDP project. Actually, in mechatronics as an engineer integrated platform, we had a course before integrated system design. So it was there, but thereafter when it came with the suggestion from ESC, so we just renamed that integrated design project, and we have redesigned something. I will discuss those things later. So again, you can see the sustainability has been emphasized. So in many places, if you go to the ESC document, the word sustainability appears 10 times. Okay, now issues of sustainability and unsustainability. So we, the engineers, are the highest contributor to unsustainability if we do not design our system considering sustainability. So we can see when we came up with the steam engine, so we were very happy. So we have improved the mobility. But later we discovered it is releasing so much of pollutants in the environment. We stopped steam engine, but still we have steam turbine. Still we have uses of coals and coal-fired machineries, and they are releasing huge amount of pollutants in the environment. And on the other side, to uplift the economic condition of the people are taking their own actions. What they are doing? Deforestation. They are cutting the forests. So these are another dimension of what we call unsustainability. And there are so many unsustainability issues, and most of the issues are actually introduced by the engineers. So here is the statistical information of total greenhouse gas emission by economic sectors in 2021. So it's very recent. So you can see from this graph who are the big contributors. We talk about electrical vehicles. So here you can see 25% is actually contributed by the electrical power. Electrical vehicles in the city is fine. It is not releasing any pollutants. But how about the electrical industries? This is power generators. They are producing this and they are burning the fuels. Of course, the overall efficiency is increasing. That is why we are still advocating this, what is called these EVs, electrical vehicles. Transportation, of course, without EVs, whatever they are a big contributor, 28%. Agriculture is very low compared to the others. Commercial and residentials are there, and industry as well. So this is the scenario of just one element, which is the greenhouse gas. But this is not the only element which is actually making our environment unsustainable. There are dumping issues also. We are dumping so many other things and stuffs, and that is also polluting the environment. So if you go to the root causes of unsustainability, so extraction of a relatively large flow of materials from Earth's crust. This is the requirement for the industrialization. If you go for industrialization, we need a lot of materials. And where the materials comes from? This comes from the Earth's surface. So we're digging the Earth's surface when making the materials out of this. And when we process the materials, we use a lot of energy. And when we talk about the energy at the back, is again releasing the pollutants to the environment. And even when we are talking about today's IT sector, they are talking about data mining. Data mining, they are consuming a huge amount of water and energy. On the what is called on the surface, if you saw, it's just computers are running. But at the back, these are the big contributors of unsustainability. Introduction and concentration of persistent chemical compounds fall into nature. So now we have synthesized chemicals, and we are in big struggle with one of a very small chemical compound, which is polyethylene. So all over the world. So next to my house, there is a supermarket. So I was still happy. They still used to provide the polyethylene bags. So I went yesterday, they stopped from 1st August. So you have to carry your own bags. This is a very small portion which we actually use the polyethylene. But if you go to the packaging industries, most of the stuff actually we cover with plastic materials. So, and we don't have any other action for those plastic materials. Still, we are using in the industries and we are producing. Physical inhibition of nature's ability to run cycles. Physical inhibition, nature's ability. So whatever we are releasing to the nature cannot, this synthesized chemical, the nature cannot absorb. It cannot be degraded. So that is a big problem. So there are three basic concepts in sustainable measure. Living within certain limits of the Earth's capacity to maintain life. Okay, so this is very, very difficult because we need to concentrate on economy. And when economy comes at the back, we dig the earth either for minerals or even for agriculture. Understanding the interconnections among economy, society, and environment. So these are the key elements of sustainability. So we need to understand. If we do not understand, so we, of course, we're going to make unsustainable environment. Maintaining a fair distribution of resources and opportunities for this generation and the next. So where comes the SDGs? The UN 17 SDGs are basically focusing this issue. Okay, let me now tell about the practice of sustainability in IIUM. IIUM started introducing sustainability under the Sejahtera Center. Sejahtera is a Malay word, which is actually the meaning is well-being. So this well-being center came up with the concept of sustainability, and they just didn't come up with the concept. They actually came up with the process, how to implement and how to make people aware and understand sustainability. With this concept, they came up with 3 modules. One is a theory course, sustainability. And another two is what is called cooperative learning base, because there's USRA 1 and USRA 2. So under this, the sustainability education, this is a 2 credit hour course, then the other are 0.5 credit and 4.5 credit hour courses. So I used to teach at the beginning of this, I used to teach this course. They call it Sustainable Development Issues, Principles, and Practices. So these courses I taught, I think, during 2019, during the COVID. So it was an online course. And these 3 courses are meant for the whole university. It's not only for engineering. Whoever are there, medical faculty, then pharmacy, law, architecture, all of them has to register this course. So this is a very good platform to know among the students, themselves know each other, and as well from the lecturers to understand actually how a teamwork of multidisciplinary background works. And the other 2 courses, as I said, the USRA in Action 1 and 2, 0.5 credit and 5 credit. USRA in Action is a prerequisite of USRA in Action 2. Similarly, the Sustainability Theory course is a prerequisite of USRA in Action 1. So they are in line. So you can see there are 3 credit hours altogether we have introduced in this. So these are the practical courses. Whatever the framework they come up with under USRA in Action 1, they actually implement in USRA in Action 2. And we generally do our activities case-based studies. So we set the learning goals, learning activities, complexity of the scenario, students' prior knowledge, and time frame. So students' prior knowledge is actually basically from the theory course. That is a 2 credit hour course. From that, they gathered prior knowledge. If you go back if you go to the taxonomical level, so these are basically the learning outcomes of this course. Okay, demonstrate understanding and awareness of different concepts of sustainable development, collaboratively play the roles of member in the society. Okay, so they actually go to the USRA 1 and USRA 2, they go to the what is called surrounding areas in UIA, they talk with the people around with the project they have in mind. So you can see here is an example of few of the projects that I supervised you in that theoretical version of the course. Within bracket is the faculty, the student. The first student is from architecture, second is architecture, third is Islamic reading knowledge, and the fourth is from ICT. Okay, and the project was rehabilitation of Pusu River. Pusu River is a river going through inside the UI. Flash flood in Selangor. It is a very big problem and a common problem in Malaysia as well. So here you can see the students are put in group from different background. And the case activities undertake observation of scenario, identify elements in scenario related to the pillars of sustainability. They are introduced to the pillars of sustainability under the theoretical course. Identify problems based on the study, propose solution to the problem, submit a report, present the report. So the communication skills are also embedded in this course. And after that, so how much they contributed as a member. So it is very difficult sometimes. So I used to conduct quizzes. Okay. So they make the presentation of a few of these, say the 5 groups. So I will ask question for all of these groups so that they know all this phenomenon. So you can see here, identify the problem of Sungai Pusu and then propose sustainable solutions to the problem. Identify the problems of landslide in Malaysia. Then give your opinion how spirituality would be able to contribute to sustainable development. As Prof. Faris mentioned, the value-based education. So spirituality and value-based is tied together. So you can see, so sustainability, if you talk about just sustainability, give the knowledge, and it is not imbued in his mind and heart, it may not work. So that's why spirituality is important. So that is why IIUM is very much active in being that spirituality. And after the grading, we find the students perform very well. So in many other courses, we don't have so many A's. You can see 14 A's, 10 A minus, and others less. In other courses, basically, it goes other way around. Sustainability in engineering. So that is, I talked about the university. Now I'm coming to the engineering. So we have a pre-IDP course we call Engineering Design and Reliability. So reliability, dependability, those were the issues before sustainability came into the picture. So reliability mostly talks about the life expectancy of the material, but it didn't consider whether it is going to be sustainable in terms of SEE. So, but when we talk about the sustainability, then we see this end of life, reuse, recycle, and all these issues. So engineers are very much related to this. And when we go to design, we have to think about the sustainability. And nowadays, there are sustainability indicators. There are two versions, 1995 and 1999, where we can actually get the sustainability indicators and we can tell so how much sustainability is our product. So material selection plays a major role. And when you choose the materials, material production, reduce the mass materials and choose the materials, select process with low energy, carbon dioxide footprint, low mass, reduces energy consumption, thermal and electrical losses often important and material dependent, and disposal, high recyclability is a strong benefit. And if we talk about the sustainability in other universities, so I have taken two examples from in Malaysia. One is MARA. They are trying to integrate sustainability in different courses. So you can see all the 17 sustainability they put at different levels in their university courses. And University Malaya is pioneer in doing the low carbon cities framework. And other than University Malaya is UTM are doing in this aspect. So carbon emission is a big contributor to the sustainable environment. So they are concentrating more on this. And there is a survey by engineers Ireland on the extent of SDG that should be covered in engineering education. So here you can see the reds are in academia and blue are in employers. So they are going hand in hand, but if you look at the quality education, which is basically in the academia, so this is here. So this is in between, so we can see they are implementing it in the field as well as in the academy. Now, challenges in integrating sustainability in engineering curriculum. The first problem is limited credit hours. We define, so in US and Canada, generally 120 credit hour to 125 credit hours degree. In Malaysia, around 135 to 140 credit hour. In Bangladesh, around 160 credit hours. So credit hour limitation is a headache. We just cannot increase the credit hours. And sustainability itself is a multidisciplinary concept with a wide range of stakeholders and knowledge. So to implement, we need the resource person. And we have limited resource personnel. Our university, when they recruit for the teaching these courses, they have to announce the whole university. But they struggle a lot. They give training. Even after that, we cannot manage people. And how to overcome the challenges? To address credit hours, some interdependent courses can be merged, merging the common items. I'm just giving an example. As for statics and strength of materials is an example. Statics is a prerequisite of strength of material in most of the universities. Now there are books available with the title Statics and Strength of Material. Strength of material, you cannot do anything without statics. So you can reduce the credit hours by 1 or 2 credit hours merging two subjects. So you can create room for a new course. Collaborating learning in co-curricular courses. As I have shown, the USRA 1 and USRA 2 in IIUM, these are collaborative learning, and these are in the co-curricular courses. So 0.5, 0.5, so 1 credit hour, but students are interested, they are working in group, and they are giving output. Problem-based learning, of course, all along this ESE, we are talking about PBL. Linking design courses to certain sustainable product system design. Design courses are in the design, so we have to give some, we cannot give a very comprehensive sustainability speech or lecture for them, but we can give the basics of sustainability, specifically for selecting the materials. And the sustainability indicators either following the Sustainability Standard 1999 or 1995, they can actually have some calculation, and softwares are available for calculating the sustainability indicators. And that will make the student know what is sustainability and how it is translated numerical. And motivational program for academic staff, because the resources are very limited. This is where resource personnel, so it needs the motivation. Now, when you got the motivation and learning, so this is the joke I will try to share. Humans are hooked, machines are learning. So how to make the people learn? Okay, and the conclusion, universities needs to introduce sustainability in their engineering curricula to educate students on the principles of sustainability. Sustainability needs to be understood in terms of real context through case studies. Real life case studies help students understand the social responsibilities in the context of sustainability. Engineering graduates must be informed about the practice of sustainability in their profession. Because nowadays, so when the project proposals are submitted, you have to show which SDGs are basically related to this project. So if they don't have the ideas when they go to prepare the proposals, they are in the dark. Okay, so thank you for question sharing. Salam.
Okay, thank you very much, Professor Raisuddin. I think thank you very much for your good presentation and a very good, informative, as well as giving some recommendations to move forward. He has given the examples of the curriculum at IIUM, as well as the challenges for us to implement this. But I guess the future trend, especially for engineering curriculum, is this service learning, meaning that how can we, from the beginning of the students' years, expose them to real life problems, community problem, and solve the community problem, and especially towards future sustainability. Okay, actually we are out of time, but if there is any one question, maybe we can, maybe Dr. Mustafizul Karim has raised his hand. Can we allow him to post some comments or question? Yeah, hold on. Can you unmute
Sure,
him?
sure.
Yeah. Can you allow him to be unmuted? Oh, yeah, okay, please.
Assalamualaikum. Oh, I'm very happy to see my old colleagues actually, Professor Ahmad Faris and Raisuddin. Sometimes I had the opportunity to talk to Raisuddin. I feel actually when should I come to Kale again? Anyway, I have one small question actually. This is we are facing for a long time. In regards to the actually credit hours, actually in OST, actually in most of the programs, actually our total credit hour is about 160, and in some programs it is 170 like this.
Yeah.
So we are actually in a difficult position to accommodate all these courses which are related to society, economy, environment, etc. Some of the people from some of the programs, they ask, oh, you put only in one subject, entrepreneurship, engineering management, economy, etc., etc. I find that these are big challenges. I don't know how to accommodate this thing in our program. Actually, we are very much bogged down with the core courses. We don't want to compromise. So this is a big challenge actually. So there is a triangular problem actually. How do you address this one? Actually?
Okay, thank you very much. So Prof. Raisuddin, you have any response to that?
I think I already highlighted that, but that was the main focus of my presentation. You can see I put the 3 courses the way we accommodated in while you had been here, we had actually what is called 6 co-curricular courses. So we now actually reduce the number of co-curricular courses, and some of the co-curricular courses, you can see 2 of them, in Action 1 and in Action 2 with 4.5 credit, 0.5 credit, because this credit hour counting is not just exactly the credit hour we count in the regular courses. So students come, meet the lecturer, they take the assignments, they work in group, and at the end they submit their report. So not much of the classwork, but they have the work, so which they have to present in reports and as well as in presentation. I think that is one of the way we are actually taking. But if you talk about the sustainability, I went to the internet, I saw in the what's called US and Canada, they have sustainability in the master's education, sustainability as few courses. I think that is very difficult to integrate. So that is why I meant in my title, integrating sustainability, so how to integrate. So design courses, we can bit by bit, you can put the sustainability. When you go to machine design, we also talk at the back. When you select the material, what is the sustainability indicator of that material? What the indicator means? The higher value of indicator means it has a more sustainability than the less sustainability. I think those are the things we need to introduce. But in real life, engineering is always like this. It's a window of learning. It's not the specialization undergraduate engineering. At the end, still, they have to learn in the industry like this. So, and as I mentioned, some of the dependent courses we can merge. Actually, in mechatronics, we have done this. We have merged actually 3 courses in 3 credit hours. Theory of machines, strength of material, and design of machine elements. The teaching philosophy is different. We are teaching basic strength of material together with statics, but statics they take separate courses. And then we are using finite element to the design. So they don't go hand calculations anymore. At least they understand what is stress, what is deflection, how it's going to affect the design like this. So that is the way we are trying to put the knowledge in them, but the theory little bit we give a touch so that they understand it. So this is one of the way we are doing. That's all.
Okay, Prof. Raisuddin, I think we have to leave it there, and then I think we have to continue this conversation, how to integrate sustainability into our curriculum without further burdening our student. So now let us move to the second presentation. Let me welcome Professor Salekul Islam from the Department of Electrical and Computer Engineering, North-South University, Bangladesh. A brief introduction to the speaker. Professor Salekul Islam is currently the professor at the department at the Electrical and Computer Engineering Department, North-South University since 2024. Okay, before that, he served as a professor of the Computer Science and Engineering at the at United International University (UIU) since 2018. And then, of course, he was also the director of Institutional Quality Assurance Cell and the director of Center for AI and Robotics at UIU, and where he guided students to this, very interesting to see this profile, to the University Rover Challenge arranged by the Mars Society in Utah. Okay, and I think I should congratulate the professor and the team for making participate in the challenge and secured top 10 places in many years. So Professor Salekul Islam got his PhD from Concordia University, Canada, 2008. And then, of course, before that, he was also visiting faculty at Anglia Ruskin University, UK. And his research area mainly focused on blockchain, edge cloud computing, network security, image processing, NLP, and robotic. He has been serving as an associate editor of IEEE Access and Frontiers in high-performance computing journals. He also has served as the organizing chair of several international conferences. He is a fellow of Institute of Engineers Bangladesh, as well as a senior member of IEEE. So I think with that, let me call upon Professor Salekul Islam, to share his presentation. Please, Professor.
Assalamu alaikum. Good day. I hope you can hear me, right?
Yeah.
Okay. So I have shared my screen.
Yes.
Okay. So first of all, thank you for giving us this opportunity, and also thank you for introducing me. And right now, yeah, as you have heard, I'm working at North-South University, but the work I am presenting right now, it was carried out at United International University, and I was a department head at that time there. And my colleagues there at Professor Shakur Shatabdo, who is right now at BRAC, but at that time he was at IIUM, and Dr. Shantanu Kumar and Mr. Tariq Hassan. So this is a kind of a multidisciplinary team. And first of all, I want to give a little background of this work. So when we were working with our application for the BITE accreditation, that is for the accreditation board of our country, engineering accreditation, we found that we could not satisfy some of the graduate attributes comprehensively. Like in our curriculum, we had little bit of those elements, for example, engineering ethics, environment, society, mainly PO, F, G, and H. I'm coming into detail later. So that at that time, we had the urge to update our curriculum. So that's the beginning point. And then we go through one after all the courses, and we found this course a very interesting course that will be very suitable to update. So what I'm presenting right now, that how we updated that course and what was the motivation and what is the end result. Okay. So if we look at the BITE requirements, BITE is the board, just I have said, and I was involved with BITE for a long time. I was also a board member of BITE, and when we were introducing the outcome-based education and outcome-based accreditation, so at that time, I was heavily involved with all the activity. Right now, also, I am working with BITE in other committees. So if we look at the manual, especially this is version 2.2, not about version 3. Right now, version 2.2 is going on, and version 3 will be in action from next year. So if we look at the BITE requirements, we find that the program must demonstrate the culmination of program outcomes, and at the same time at the level of solving complex engineering problems. So for that, the suggested way was, because they are using preferably through a final year design project or capstone project. And also the program must demonstrate like how the attribute of different knowledge profile are addressed in the curriculum. And also the program must demonstrate the attribute of range of complex engineering problem and activities, like how they have incorporated in teaching, learning, and assessment. So since this is a preferably, so that means the program can also demonstrate culmination of peers through any other method, like other than the final year design project. So at that time, when we updated the curriculum, the curriculum was for bachelor program of computer science and engineering. So we introduced final year design project, but our target was also to find out one or two suitable courses where we can also demonstrate the complex engineering problem. And another thing is we have to understand that CSE, or the computer science and engineering, is little bit different than other traditional engineering, because in other traditional engineering like sustainability or engineering and society or environment, those are integral part of a design. Like when you will design, definitely you have to think about a sustainable design and how the design, like it is impacting the environment and all these things. But for computer science background, this is little bit like you cannot directly correlate those issues. Like for example, when you are designing a software, this is little bit difficult to think about these issues, but definitely these issues are there because we are part of the society, we are part of the environment. So that's why the challenge is how we can introduce these topics or issues in front of our students. Okay, so that was one of the challenges. So we found that at that time we had a course, and the title of the course was Society, Environment, Engineering, Ethics, and this is the old curriculum of that course. So it has 5 course outcomes, and like a student will have the ability to explain the relationship between society and technology, or will be able to argue the importance of engineering ethics, identify and explain environmental concept. So these things are there. And we also had a course outcome and the mapping between course outcome and the program outcome. Here POF means the engineering and society, and POH is the engineering ethics, and POG is environment and sustainability. But at that time, this course, like these are the different assessment types, and you can find that like it was heavily dependent on like for example midterm and final, or this assignment was a simple assignment, and this was not a term paper type or a group project. This was just an individual assignment. So this old curriculum, the assessment was mostly summative. This is one drawback. And the biggest challenge was it was taught by the faculty members from School of Social Sciences. So the faculty members from School of Social Sciences, they are definitely very knowledgeable, but they don't have a clear idea about the relationship between society, environment, and engineering with computer science and engineering. So the course was taught from the point of view of social science, and the idea was then that students will map these issues by themselves with their own domain. But you know, like this is a little bit challenging from them. And at that time, we found that the questions were mostly addressed at the lower level of Bloom's taxonomy. And so our understanding was we could not address the complex engineering problem as required, like by the BIET, and like we could not address professional ethics and responsibilities from computer science and engineering point of view. So therefore, we could not use this course to appropriately to meet the BIET's requirements. So that was our motivation, like why we were there. So then our objectives were we want to develop the course outcomes, like we want to redesign and revisit these course outcomes so that we can include the solution of complex engineering problems there. And we need a multidisciplinary approach in teaching, learning, and somehow we have to blend the expertise from social science and from computer science and engineering. So finally, what we designed, that it's a kind of unique design, that the course will be taught by 2 faculty members. That means 2 faculty members from 2 different domains. So the first half of the course will be taught a faculty member from social science, and the second half will be taught by someone from computer science and engineering background. So I'm going through the slides, like how we designed that. And definitely we have to design the assessment tools so that we can support those updated syllabus. So that means we have to develop a new curriculum. So if we go through the BIET program outcomes, at BIET we have 12 program outcomes. In fact, BIET just adopted the Washington Accords graduate attributes verbatim, that's word by word. So in Bangladesh, almost all the programs, they also adopted these 12 program outcomes without any modification. Hardly I have seen maybe 1 or 2 programs, they have modified these program outcomes. So it's kind of a de facto program outcomes, and which is not a bad idea. So here, if we go through this, I think from the morning we have also already seen these program outcomes, that complex engineering problems are there from all of these, like for A, B, C, D, that is PO 1, 2, 3, 4 here, and like E also in F, and the relevant knowledge profiles are also there. I think 1 or 2 microphones are on. I'm requesting. Okay. So, and the relevant knowledge profiles are also here. So, if we summarize this program outcomes, then we can see that from A to E and also from F to H, in all these program outcomes, the complex engineering problem is an integral part. So the idea is the students will learn these program outcomes through solving complex engineering problems. Like they can also learn this. Okay, I'm requesting the organizer. Okay. I think you can hear me, right? Okay.
Yeah. Okay, go ahead. Yeah.
Okay, sorry, thank you. So the idea was the students will learn these program outcomes through solving complex engineering problems. They can definitely learn these program outcomes without also solving complex engineering problem, but in the curriculum, there should be that provision that they will learn these program outcomes through solving complex engineering problem. And another important part, that is complex engineering activities, that is mainly part of communication. So the knowledge profile part, if we go through this, we have 8 knowledge profile. So we can also like divide that from K1 to K4. Those are mainly conceptual, what or why, and then these are mainly for contextual. So these are the knowledge profile. I'm not going to detail here. And this is how the complex problem solving has been defined. So here we know that P1 is a mandatory one, that is the depth of knowledge. And from P2 to P7, mostly we should address at least other 2. So mostly there should be at least 3 of them to be a complex engineering problem. And these are the complex engineering problem solving, and these are the complex engineering problem activities. Now, if we go through the literature, like the literature means the work, those are kind of related to our target or our objectives. So here we have found a few similar works. For example, this one, where this is a field work in India to examine how students were able to experience cultural and ethical challenges. And this is also for the studying the engineering students' perspective. And so this field work, the students directly engage with complex problem facing, and like they target PO6, that is engineering and society, and PO8, that is ethics. So this is another one. And here they studied how curricula for developing students sustainability motivated them and to be aligned with global societal challenges, for example, gender equality, public health, and access to clean water. So also this integration enabled the students to understand the greater social awareness, that is PO6 and PO7. And this was also published in this journal. Another one, here the author expanded on social integration, and so they explore how far the societal dimensions were integrated in Swedish engineering programs. So here they found that societal competencies are too often not represented in engineering curricula. So the structured faculty training was proposed, and this is just like they proposed how this training will help, okay? And this is another work where the author explored how sustainability principles like life cycle assessment and sustainable design are embodied in two different university courses. So, and this is also another work, and this is a systematic review, and they showed that interdisciplinary methods as well as reflective assessment, if we do those things, then increase the sustainability competencies. So in short, we could not find any specific study for computer science and engineering curriculum. Most of these studies are for generic engineering, not specially designed for computer science and engineering. And most of the studies are need assessment, like what we need to do, and then they recommend it. But most of those recommendations are made without implementation. Like they have not implemented their idea, and then they have not seen how it works, okay? And another thing is not interdisciplinary design, okay? So those are our motivations. So when we revised, or like when we went through the assessment, then we found that, for example, if we go through the previous questions, because we have seen that those are mainly based on like heavily dependent on midterm, final, and those written text. So here, for example, one question was define sustainable development. So this is mainly from the remember level from Bloom's taxonomy, and definitely we encourage for memorization. So if we revise that, for example, compare two case studies on sustainability and justify the ethical decisions, then definitely it will be like it will allow, or it will provoke the students to think, and we can easily address the higher levels of Bloom's taxonomy. Or for example, another question, what is engineering ethics? So this is just, we are testing the understanding. So this is clearly lack practical application. Maybe we can think about analyze an AI ethics dilemma and propose the solutions. So these are a few examples that we have seen. So that's why we found that we have an urge that we need to revise the course outcomes. For example, one course outcome, like, or part of the course outcome was explain the relationship between society and technology. So this is kind of vague, too generic, and there is it lacks analytical depth. So we revised it for example, analyze how technological changes shape the societal structure. Or another one, argue the importance of engineering ethics. So this focused only on theoretical discussion, no practical application. So maybe we can design like evaluate ethical challenges in AI, computing, and data science. So this way, we revise the course outcomes. And now one course outcome is mapping to only one course program outcomes to be specific and goal-based. So here, the course outcome one we have designed, the students will be able to explain the interactions between societal structures and technological development, specifically focusing on how basic social institutions influence and so on. So here, we have found that these course outcomes are like more focused, and here students will be able to relate between computer science and engineering, because this course has been designed in such a way that it should not be offered in the first year or even in the second year. So this course has been designed for the mature students. That means by that time they have studied, or they should have a basic idea about their own discipline, that is computer science and engineering. So now they can easily relate their background knowledge with society or environment and sustainability. So if we go through the revised content, I'm not going to like the detail here, but if we go through here, the idea was the first half, that is from 1 to 12, will be taught by a faculty member from social science background. And the second half, that is from 13 to 24, that will be conducted by someone from computer science and engineering. And here we are going to explain like social responsibilities of engineers, engineering code of ethics. We have one very well-known code of ethics that is designed by IEEE and ACM. And here is one case study. And if we look at the 9th one, there is another case study. So these two case studies are different, and the ethical challenges, the human-computer interactions, and all these things. And at the end, there is another case study. So the teaching learning assessment method has also been revised. Previously, it was mainly lecture-based teaching. And for that reason, the minimal student engagement and lack of discussion. But now there are several case studies and the problem-solving discussions. And it was mainly based on textbook learning. But now there will be a term paper, and that will be a group project. So they have to work even outside the classroom, and there should be some kind of self-study by the students. Previously, it was individual assignment, and it carried only 10% of mark. Like we all know, like if we allocate a small portion of marks, then most of the times students are not that much serious. But now the term paper, it will carry a good amount of mark. So here is the revised assessment, and the term paper itself will carry 25% of marks. So there will be still, we have midterm and final, but we have reduced the mark allocation here. So what are the, like after implementation, the course has been designed, and we have already offered this course for a few years. And so we have observed the effectiveness. So what we have observed, we have also evaluated using both qualitative and quantitative metrics. Here we are not going to present those details yet, because we are also still working on that. In fact, we are working on a journal paper. So that's why we are not presenting those intermediate metrics, but we have studied in depth, and what we have found from student performance analysis, it improves in higher order thinking assessment, and that is from the students' performance analysis. And from faculty point of view, when we surveyed the faculty members, they have said that it increased student engagement in discussion. And from the student feedback, we have found that they have like indicating greater appreciation for interdisciplinary perspective. And from program outcomes attainment, it improved and meaningful attainment of POF, G, and H. So these are just some snapshot of CU assessment. So all are above 70%, 75%. So we are satisfied with this CU assessment. And here, from those term papers, these are a few topics that students selected. And the idea is these term papers, the student group, they will find the problem by themselves, and they have to propose the problem in the middle of the course. And at the end of the course, they have to submit a term paper. There is a well template for the term paper. And we also have a good number of conference papers, and maybe I think a few journal paper also from these, like from the extended version of these term papers. So if you are here, for example, an artificial intelligence-based framework to achieve the sustainable development goals in the context of Bangladesh. Cyber crimes, what an engineer can do. Or another one, say, ethical concerns in COVID-19 related applications, ethical concerns in robotics. Or, for example, the user privacy from an engineer's perspective. Or, for example, right now we use facial recognition in several systems. So are we using those ethically? Because, you know, like there is use of ethical AI, that is an emerging topic and a very important topic these days. So mostly that's all. So in the future, we want to extend it for GAPC 4, that is for bike manual version 3. And we want to follow this pattern, maybe other core courses like artificial intelligence, Internet of Things. And we need industry involvement in case studies or projects. So if the projects might be partially supervised, or maybe the problems can be given from the industries, it will be more interesting. So that's all from my point of view. So hopefully I am within the time limit. Yeah, I'm sorry if I have crossed the time. So okay. If you have, I'm here, happy to answer.
Okay, thank you very much, Professor Salekul Islam. I think you are doing very well in terms of time, and you also, I mean, thank you very much for a very good presentation, sharing how you, I mean, revise and improve your course to satisfy the requirement, and you also have a future plan for that. That's very good. I see there is one question from Dr. Said Matsum Ahmad Chaudhry. Professor, can you allow him to ask question?
Yes, definitely, please.
Yeah.
I think
Yeah, the organizer, can you, yeah, okay, please.
Yeah. Thank you very much. Thank you very much, Professor Sadiqul Islam, for your excellent presentation. I've been working for Bangladesh government for last 30 years. Actually, I am not a full-time faculty member. I usually go for some part-time faculty in different universities, and I have a passion for this technical education. And I had an opportunity to work in the technical education ministry as well. So from that perspective and experience, I would like to just supplement, or you can say some question as well. That you said that there are so many steps you are taking in the universities in your university as well as other universities. But what I feel that there is a gap between the universities and the government policy level. Especially in our country, there is a University Grants Commission. They, at the different times, they come with some proposals and decisions, as well as the ministries are there, and they comes up with different suggestions and proposals and rules and acts. So what would be the mode of operation for this combination of all these policies and steps for sustainability of this technical education? Say, for example, most of our engineers, when they go to their practical jobs, they have to face some procurement activities. And there is a definite procurement act and rule is there in place in Bangladesh. But most of the engineers are not very aware with this in their curriculum. So like this, there are some gaps, what I feel. So is there any suggestion to bridging up these gaps, Professor Sadiqul Islam, if you highlight this? Thank you very much.
Yeah, thank you. Thank you for the question. Say, for example, right now, we are developing or we are finalizing the AI policy. If I think about this course only, like if I concentrate on this course only, say, for example, we don't have any AI policy right now, we are finalizing. So those types of policies, or like if we have any software development standard or for environment or for SDG, if the government, they have some policies, then those are, we can easily relate those things with this course. Okay, for example, like students can design solution that will satisfy those policies. So those will be very interesting, but we don't have enough policies or materials right now. We are working on it. We all are learning. Definitely we are behind. And what you have rightly pointed out, UGC can have a good role here to disseminate all those things here.
Okay.
Thank you very much.
Okay, Professor. Again, I think we'd like to thank Professor Salekul Islam for very, excellent presentation. So I think we have to move on because of the time, Professor.
Yeah, thank you.
Okay, thank you very much. So the next presentation is will be delivered by Mr. Sakib Hossain Khan from University of Portsmouth, United Kingdom. A brief introduction to the speaker. Mr. Sakib Khan is a researcher and doctoral candidate at the University of Portsmouth, currently pursuing his PhD within the Faculty of Technology. His academic work focuses on sustainable materials engineering, with particular emphasis on the development of biodegradable, biocomposites, and circular economy applications. Mr. Sakib's research aligns with global sustainability goals, exploring how natural fibers, especially agricultural waste like date palm fibers, can be transformed into high-performance, environmentally friendly composite material. He has authored multiple peer-reviewed publications and continue to contribute to the field of green engineering through his doctoral research. His work reflects a blend of scientific rigor and a practical vision for sustainable development, positioning him as an emerging expert in the field of biocomposites and eco-friendly material innovations. Of course, he also has some teaching experience at the Ahsanullah University of Science and Technology, where he got his degree. So with that, I would like to, welcome and invite Mr. Sakib Hossain Khan for his presentation. Please, Mr. Khan.
Thank you. I'm joining with two devices because one of this device will be on the video and I will be presenting on the other one. So thank you so much for the introduction. So, hello. Yeah, am I audible?
Yeah, you are audible. Sakib, please share your slides.
Okay, sure, sir. Yeah. Is my presentation visible?
Yes, yes.
Okay, so I'm Sakib Singh Khan. As the introduction said, I'm still not someone of a big researcher, but I'm a new in the field of research, and my focus is on sustainable materials because as I'm a mechanical engineer and both a manufacturing engineer, so my combined area of research is materials with a focus on mechanical and manufacturing sustainability also. And I chose this idea of curriculum because I'm currently working in a course where we focus on sustainable practices in material engineering, and most of the universities in UK, they do have a standard now in on setting up a sustainable understanding in their courses. So from that perspective, I'm just presenting my understandings. And so the idea of sustainable material is we hear this term a lot, and there has been a misunderstanding with this term, whether like we say everything as a sustainable materials, natural fibers and everything, but the idea of sustainable material has to be analyzed, has to be supported with evidences, has to be supported with scientific understanding, rather than just we term something as sustainable. It has to have their whole what you call it, life cycle, which I will be discussing in detail. um, has to be there, evidences has to be there. So in order to understand a material, we have to understand the environmental impacts that the materials has, and the resource, and how we use those resources efficiently. And also, one of the most important thing that I found is the sustainable materials, but we don't think about end of life, because in the end of life also they may not be as sustainable as we thought. So there has been a lot of paper published in making sustainable materials, but once we try to do the life cycle assessment or detailed rigorous assessment on the material, we found that this material is actually less sustainable than the synthetic material to some extent. So there has to be a holistic approach where we understand the extraction process, to the manufacturing, to the use, and to the disposal of the materials. And one of the core principles of understanding a material, whether it is a sustainable or not, is the life cycle assessment. Because the life cycle assessment is one of the tools. I will not say the only one tool to understand the whole circularity or the whole sustainable aspect of a material. But yes, life cycle from cradle to grave does provide us a deeper understanding of a material. And also the circular economy concept, where we are transforming from a linear economy to a reduce, recycle, reduce, recover, recycle, or we term it reuse. This concept of 3R concept in circular economy, and then we are started adding new terms on the circular economy targets. And also the efficient resource use, whether we are producing, for example, we say natural fibers, and we end up using a lot of water and chemicals to treat the natural fibers, and then it's still not sustainable anymore, because we had used a lot of resources in extracting the materials. And also there is social and ethical responsibilities in understanding a natural material as a sustainable. Like, we have to understand whether the materials we are in use has an impact. Like, for example, we in Bangladesh, there has been a thing going on about the jute packaging material to replace the plastic or polyethylene materials, and then whether this one is financially or in terms of our socio-economic perspective, is it reasonable? And finally, the overall understanding of life cycle thinking, because even as an individual person, we have to understand the effect of life cycle thinking. We have to understand the concept of life cycle thinking. It's not just, it's a part of our lifestyle, and whether we waste the resources or we don't waste the resources. And that's what the basic understanding, and this is what we should implement as an academic to the students, that they will have a life cycle thinking. It can be for any engineering field, for civil engineering, for sustainable constructions, for textile engineering, for sustainable fashion, recycling of cottons, for mechanical engineering, sustainable materials and manufacturing practices. So there has to be a whole lifestyle and a whole life cycle thinking going on around it. It's just not going to be focused on just, we do a life cycle assessment and we say this is fine, it has low emissions and everything, and this is all good. So this is the life cycle basic framework that does mostly been implemented, where we understand the goal and we do the inventory analysis, and then we do the impact, and then in between all of that section we do an interpretation. So and then with the focus on, we focus on the product and improve product development and planning and the policy making and marketing and others. And the life cycle assessment has not been implemented in any engineering courses as a main focus for a long time, because it does provide engineering education. Because if we study material, because I'm talking about material engineering or material science or mechanical engineering, we do have material engineering courses, and we often talk about metals, alloys, polymers, plastics, and if we provide them an understanding, even a basic understanding of life cycle assessment, which they can relate to what materials they are using and what is their impact on environment and social behavior and everything around it, it does provide a good knowledge base for them for the future. And also the whole life cycle thinking surrounding it. So the life cycle thinking comes with the life cycle assessment. It's just within it and it's bounded together. And we do life cycle assessment and then we do research. Whether, because sometimes I found, because I would share one of my experience where we had done life cycle assessment for PLA, and we found it that PLA is less friendly than the PP. So there are studies, because the energy does produce and also the produce to produce it is very much energy consuming. And also we evaluate and we map all the factors related to the life cycle thinking. And there are okay. So in terms of metal, this is quite established that the metals can be recycled, and we used a lot of recycled materials, whether in the Europe or North America. There has been recycling of metals going on, but the production of the material, the furnace and the melting of the material, steel, we use a lot of carbon emissions. There we use gas and oil, and there are alternative methods that has been on research for a few years. And I'm not a metal person, so I can just talk about the overview of the circular strategies. But there has been a research going on in the material circular understanding and the behavior. And my focus is on the polymers and the composites. And the polymers and the composites is a kind of area where we focus on the fossil feedstocks, and we use PE, PET, and PVC a lot in our daily life. And they have a significant GHG greenhouse gas emissions. And the way we use it now is mostly in the Europe, we do have a very good recycling process, and whether it is a mechanical recycling or chemical recycling, and the life cycle does shows that the recycling costs energy and also costs the greenhouse gas emissions. So life cycle is one of the most essential tools to understand. Even the use of the fossil feedstock is not bad, but if we recycle it responsibly, we can understand, because we do promote, as a researcher on bioplastics, I do promote bioplastics, but still the recycling is the option. We do have a lot of non-sustainable polymers or synthetic polymers in the nature, and we have to recycle them. Whether the recyclability does or does not enhance the property or does not retain the similar properties, this is a matter of discussion. But and also the bioplastics like starch or PHA or PHB or other cellulosic materials, they are renewable feedstocks. But also the LCA, what we found doing the LCA of this type of materials is that there are a large agricultural land use in there, and this also have a high carbon footprint. So the overall idea is we have to encourage engineers to design for end of the life materials. They have to think about what the material or whatever I'm making, it has an end of life, and after this what will happen. And so now this is the main topic that I would be discussing. I'm just giving an overview. So why sustainability matters in engineering education, why we are focusing on sustainability, why we are just not making anything and that is just performance based and like that. Because in the past there has been a focus on performance driven. We had developed Kevlar, we had developed carbon fibers, we had developed high performance materials. But now the research is going backwards into more sustainable materials, and that's what it is. And we have to educate our engineers in a way they can think that yes, they need to make performance driven materials, but they also have to think about the sustainable aspect, and they have to deal with the resource efficiency, they have to deal with the circularity, they have to have the ethical responsibility in their mind. It's just not the performance, it's just not a high performing material. And also there has been a lot of work has been going on to integrate sustainability into different courses, but basically in mechanical engineering or in material engineering, there has not been any courses. So for example, there are different ways we can do piggybacking, like add just a chapter on a material engineering course, and you add a sustainability of materials. And I don't think this, and also the study shows that this does not help actually. And also if you are mainstreaming it, how you are mainstreaming is a problem. So there were ways we can do it. We can specialize our engineers in sustainable understanding or sustainable materials, and also connect them in a broader disciplines like other aspects of environmental science and social sciences and everything, and we bring them together. And yeah, okay, so these are the common layout that I had found it that can be done to bring the sustainable aspects into the engineering education, or basically material engineering education. And one of the main thing is the active and experimental learning, which I will discuss all of these points one by one. And the project-based learning, we do have a problem-based learning for a long time, but the project-based, I will discuss why project-based learning does provide a better understanding than project-based learning. And then the case studies and the real-world examples and interdisciplinary, and also the interdisciplinary approaches and the reflection and the ethics. Okay, so why so why we should understand, like, why the active learning, which has been termed for a long term, and we say active learning, and how this active learning does have an effect on material engineering or material science subjects, how the active learning can can be relevant in this field. For example, a student discussing a project. For example, in there is an initiative running by Cornell. I followed their work for a long time, and they do an active learning initiative where they promote the students to think, discuss, investigate, and create something rather than just passively listening to lectures. So my understanding, even there are reports that shows that the active learning increases the scores and the number of the student passes. So yes, there is a strong evidence, and even we understand that active learning does, as a student, we used to be students, so as active learning does provide help rather than just knowing that the material property of this has a tensile strength of this and that, and this is how this works. And also the another aspect is experimental learning, where we focus on hands-on experience and create something. And also what we do here in Portsmouth is we emphasize on performing the life cycle assessment of the materials. And in all of the courses, in the courses that I'm dealing with, they have a section of where they perform, even the chosen material they had chosen, they perform life cycle assessment. And whether we are testing bio-based composites or recycled composites, or we investigate either non-sustainable synthetic plastics like PET or PP, and we understand the material degradation or how we can better recycle it. So another field that another project that I found is very interesting is the Northwestern Life Cycle Party, where they built in the first year, they built something in the lab in every engineering, mechanical, or either industrial or manufacturing. They have a project where they build something, and then at the end of the project.
Mr. Sakib, excuse me. I mean, can you wrap up within 5 minutes?
Okay. Yes, I can. Yes.
Yeah.
Okay. So yes. So the life cycle party, where they focus on the life cycle party, where they focus on recycling the materials that they had used to build up their project. So, for example, I had seen when I was a university teacher, the students built something and then they just left, and it was there for years and years, and then we have to hire someone to dispose that. So also in our University of Portsmouth, we are avoiding this thing. We are using the materials that some other student has built in the previous year to recycle, because the person who has built, they knows the best way to recycle it because they had collected it from wherever. So they have to keep it back to the stock so that the next student and the next people can understand, because we have to understand that we use a material and we just don't throw it. We have to have an end life of this, and the students must understand that every material does has a backstory. And also the active learning, as we have seen, like active learning does provide a belongingness, because they work in a group, they try to understand and help each other, and this does provide equality, inclusion, and belonging. And also the project-based learning that there is a long emphasis going on. It's we implement in the project-based learning the sustainability aspect. We have to ask them whether the way the creative design or analysis and everything they are doing does have a sustainability aspect on this. And how do we construct? We have to set them a sustainability goal. Like, for example, just say like we have to reduce the carbon footprint by 50%, or we have to have them the context at which place and which country they are working on, and those peoples are involved in this, and also whether we are doing justice to the nature, to the people, and to the system. And also finally, there are things that is not known and there is unknowns. For example, there are some materials we still don't know their behavior and their emissions and their impact on the environment. So they has to take all of this into account. And there are few good recommendations which for a sustainable, for a successful PBL with an integration of sustainability. And there has to be, the sustainability has to be within the curriculum, which I will explain later. How do we integrate that in the curriculum? And also the faculty must be provided enough support so that they can have those, they can guide the students into the sustainability aspect, rather than just giving a course and giving not faculty the enough support for the sustainability is not going to help. And the assessment has to be structured, because we also has to assess them as a student. They has to be assessed at the end of the day, and we also have to assess them properly and in a structured way so that they can understand sustainability at the heart of the sustainability. Okay, so this is a case study because I'm working on plastics and plastic materials and plastic waste, and also we do have a center of Revolution Plastics where we study microplastics, and I have collaborators here. So there is, for example, the cosmetics industry. There is a lot of microplastics waste released from there, and this goes to the marine life, and there is no way this microplastics can be recycled, because microplastic itself is a big problem. And if it is a whole micro scale plastics is fine, but if it is a micro level materials, we no way we can extract it, and that is a big issue. And the student has to understand, for example, they work in a company and they will go to work in an industry where they can opt for a sustainable option and something that is harmful for the nature, because the company's way is to drive profits. But now you can see the companies are also moving towards a sustainable goal. So the engineers has to be trained in a similar way. And also the interdisciplinary approach, like for example, being a mechanical engineer or a material engineer or a manufacturing engineer, there has to be an interdisciplinary approach between an environmental engineering perspective and also the socio-economic perspective. So there has to be different disciplinary or interdisciplinary approaches to the sustainability. Not just bringing a course in the curriculum is going to help. There has to be a whole system of people, and all the disciplines must come together to bring up a solid foundation of sustainability. And also the important aspect is ethics, and we have to question as an engineer, whatever we are making, whatever projects we are working, we have to be ethical. We have to reflect on ourselves, that whether we are designing something that is not going to harm any living species or the environment. And I would just skip this slide, and I would just go to the implementation strategies. For example, the basic way of implementing this sustainability aspect is to bring this in the intended learning outcomes, ILOs, and with a focus on teaching and learning activities and assessment. And also we have to focus on the high level cognitive domains where we evaluate the environmental and socio impacts. And also we include an effective and behavioral dimensions, like where they can question the ethical reasoning, and they can have a solid reasoning of whether this is right or wrong. And then they can have a teamwork where they will have a like-minded of people who focus or driven by the sustainability to come forward and work together.
Okay, Mr. Sakib. Mr.
Yes.
Sakib, I think can you conclude now?
Yes, just 50 seconds.
Yeah.
Okay. So yes, and the teaching activities and the assessments has to be with a open-minded and with the sustainability aspect. So yes, these are the conclusions and the takeaways I had. Is the life cycle thinking is the key, and we have to build this as a base for the students. And the greener innovation and the education should integrate LCA, circular economy, and ethics. Also the ethics and everything has to become the feedback from the industry and the policymakers, not just the industry, because now the policymakers does provide a strong role in bringing the socio-economic concepts in all fields, and they have to be driven for a sustainable future. That's it.
Okay, thank you very much, Mr. Sakib. I think we thank you for a very good presentation, good inputs, and I would say good recommendation also for us to implement greening the curriculum. Uh, uh, I mean, for such sustainable practices in, I guess, all our curriculum. Okay, due to time limitation, we have another presentation, but we only have 20 more minutes for this session. So I think if anybody has any question for Mr. Sakib, please, you can either send him a message or email him. Brother, Mr. Sakib, can we do that?
Yes, no problem. No
All
problem.
right. Okay, thank you very much.
I'll give in my email address.
All right. Thank you very much for your presentation. Okay, our last speaker for this session is Professor Peter Hasle from Department of Technology and Innovation, SDU Global Sustainable Production in Denmark. So let me introduce briefly the speaker. So Professor Peter Hasle is a professor of sustainable production at the University of Southern Denmark, and also he is also an adjunct professor at the University of Greenland. So welcome, Professor. I think it's early morning in Denmark now.
Yeah.
Professor work focuses on the intersection of organizational performance and employee well-being, with a strong emphasis on how companies can build healthier workplaces without compromising productivity. He is internationally recognized for research that blends systems thinking with practical tools to improve working conditions, especially in complex or globalized production settings. His expertise spans occupational health, organizational psychology, and industrial operation. He has many projects. Among his notable project is a project on safety and health audits in Bangladesh. He also have this project called Lift OSH. In this European project, he explored how large companies can use their influence in supply chains to improve occupational safety and health conditions in smaller subcontractors, focusing on sectors like agriculture and construction. Other projects like participatory approaches to prevent musculoskeletal disorders, as well as he has a project on work environment strategies in Greenland. Professor has published more than 100 peer-reviewed articles and book chapters. His research has had both academic and policy impact, often contributing to national strategies and international guidelines on occupational health and organizational development. With that, Peter Hasle, I would like to welcome you and invite you for your presentation. Please.
Thank you very much for this kind and impressive introduction of me. And thanks very much for inviting me for this important conference. It's a pleasure to be here, and it's a pleasure to do something together with AUST, where I did my first and largest project in Bangladesh about lean productivity and safety and health in the garment industry. So today I'll try to share my slides. Hope it works. Yeah.
Yep. Coming. Yes.
The full slides on your screens?
Yes, I think we can see your full slide. Please go ahead.
Yeah. So for today, I will present some of the challenges in supply chain management related to sustainability, some of the developments, how it's regulated, in order to emphasize why sustainability is a topic needed for supply chain engineers, as well as for production and operation management engineers. So first point is to say that there has been a movement from what you can call operations management to supply chain management. We have the traditional production, if we go 25, 30, 40 years ago, where we mainly had production organized in independent units, manufacturing more or less a complete product, buying raw materials and parts on an open market and selling to an open market. That has completely changed today. So now supply chain management is dominating, even for production engineers, operations management, because all organizations, they have to consider make or buy. What are we doing ourselves? What are we buying to put into our products? And production is separated in still more specialized components. So most production is only making a small part of a complete product, and in the end it's assembled, but all the parts, they are produced other places. So we end up with large production networks. So we call it a supply chain, but basically it's a large network. I'll get back to that later. And we get more and more dependent on suppliers. So we specify price, quality, and delivery, and that means that upstream suppliers, they lose control. I'll get back to that again. If we look at some of the developments, then we need to notice that supply chain disruptions, they are getting more and more frequent. They are having larger consequences. It's due to wars, it's due to Trump tariff, limited resources, limited capacities, as the picture is showing, that you end up having this large lorries, containers jamming and cannot get out of harbors. So many of these kinds of problems. So it ends up then with these complex supply networks. They are getting more and more dependent on their suppliers. Disturbances as large consequences. If we remember when a ship blocked the Suez Channel, then the whole globe was disrupted just with a blockage of 1 or 2 weeks. It also means that there are closer and closer cooperation between buyers and suppliers, less shopping around, because that can be leading to opportunistic behavior from suppliers, building longer term relations, depending on a committed supplier workforce, so we can be certain they are delivering. Some developments which can also be supporting sustainability development. And then we have, which is important also for sustainability, the reputation risk if they don't care about sustainability. So we can say that sustainability, it's moving from proximity to distance, because each individual company, they have in principle the responsibility for sustainability of their own workforce. It's required by legislation, being a legitimate company, having a committed workforce in its own operations. But in principle, the buyers, they are distanced from suppliers' production, and they have no direct interest in sustainability of the suppliers. So we have a distance there. And the result of that is millions of unhealthy jobs and serious environmental degradation, because this link is not by the market created so that the buyer is taking responsibility for sustainability at the suppliers, and the suppliers, in order to be competitive, they tend then to provide poor jobs and damage the environment. So luckily, we have the emerging agenda for sustainability. It already has quite a history. Before the millennium, we have a number of activities, mainly from the UN, the Brundtland Commission, starting its Rio Declaration, Kyoto Protocol, UN Global Compact, ILO conventions, not least, which I didn't get on, the Paris Agreement on climate. We have recent developments pushing much stronger forward on these issues, mainly with the EU making new requirements on ESG, environment, social and governance, performance and reporting. We have modern slavery acts requiring due diligence, and then we are having more broader due diligence requirements coming up in individual companies and are coming or approved EU directive, which would be enforced from 27. So we can say, why are sustainability interesting for supply chain managers and thereby also for supply chain engineers and supply chain engineering students? We can say that traditionally you operate with price, quality, and delivery. So that's what the supply chain manager is caring about. But with all these initiatives I just presented, SDGs, ESG reporting, due diligence, the buyers, they are meeting sustainability demands. They are meeting it from customers. They are risking more expensive and lower quality products if they are not sustainable, delivery disturbances, reputation risk. They have national and international regulation, and they also risk that suppliers push problems to one's own company. For the other way around, the one sitting in the suppliers trying to control these matters, they also have the customer demands. They have problems with quality, and some of the same problems for both of them. Then just briefly, what's sustainability? The most famous and used definition is the Brundtland Commission from 87, meeting the needs of the present without compromising the ability of future generations to meet their needs. So one definition, and then it's often making operational in the people, planet, profit, or triple bottom line when you talk about the company accounts and financial accounts, that you need to have sustainability on all these three issues. And then it's now detailed in the SDGs, and some of these have been mentioned already in the conference, of course. The development is not particular positive. One estimate made in 23 told that we are actually having 3 SDGs going backwards, 3 improved slightly, 7 no development. So we are not really reaching the goals of 2030. We have also a problem with looking at the environment and climate, that what is called planetary boundaries, that we are exceeding 6 out of 9 planetary boundaries, and we have no real positive development. So these are telling that it's very urgent. And then we have the problem with just transition. ILO is focusing a lot on that. EU is also focusing a lot on just transition. The problem is that if we go for climate and environmental sustainability, and it's then pushing the burden to the working poor, then we are creating imbalances in our society. We are creating poor conditions, and we are creating social disturbances, which we have seen in many countries, and we also see as the outcome of elections in many countries that the poor, they don't accept that sustainability, that they have to bear the burden of sustainability. If we then go a little bit into the supply chain relations, we can say the most fundamental thing is this buyer-supplier relation, that a buyer make a contract or an order to a supplier. The supplier, in order to deliver, need resources, money, finance, humans, materials, machines, in order to produce. And not least, which is often overlooked, is that the supplier also need to be a legitimate company, has what can be called a license to operate. If people around the company, customers, employees, media, authorities, don't accept the company, then you cannot operate but run into problems. And then we have, of course, for both sides, that the supplier create a work environment for their employees, and has relations with the environment, and the same for the buyer. In reality, then, we need to emphasize that it's getting much more complex than just this exchange of a product, information, and money, because they are tier 1 on both sides, they're tier 2, and then they are on each side, there are numerous others having the same exchanges. So it's very difficult to manage and to control, and that's part of the problem we have in this field. But then we need to work with the basic dyads, because that's what to be controlled. And when we do that, we can see that suppliers, they're influencing, they're pushing some elements of work environment and environment to the buyer, to the next buyer, the next customer. They are then making demands. You need to control your environment and your work environment. And they do that in governance, where we have basically two forms, contractual governance and relational governance, what you can formalize. But not least, and what is often overlooked, is that there are also relational governance. Do you trust each other? Do you communicate? Do you have a dialogue? Do you share development? And in reality, we need elements of both. So if we then look at how then to control, use governance to do something about sustainability, we can say that we have a direct influence aimed at sustainability, where we use code of conduct, reporting requirements, certificates, audits, due diligence in the contractual form. And then we have supplier support, training, advice, shared development on the relational part. But then a large element of the influence on sustainability is the indirect, the supply chain management of price, quality, and delivery, where you have orders, fines with late delivery, duration of contract, payment terms, which is then giving the suppliers the frames for their sustainability work. And also the relational, whether you communicate about needs and expectations, whether you share product developments, and so on the relational part. And to a large extent, it's the indirect influence from supply chain management which will have the largest influence on sustainability. Then briefly on regulation, if we start with work environment and human rights environment, the first thing we need to establish is that the market cannot regulate by itself. And we have seen numerous serious consequences in Bangladesh, not least the Rana Plaza accident. The market cannot control this. We need to have other means of doing it. And the reason for that is obvious. A company exists, private company, to produce and sell a useful product, create profit for owners. For public organization, meet citizens' need, effective use of tax money. And therefore, they are not established to be sustainable. They are established to fulfill their purposes. So we end up with having work environment, human rights environments pushed on the sideline. And we have cost for work environment only accepted if there are shared terms due to competition, if it creates a competitive advantage with also ethical choices. Of course, many owners, they appreciate that. But we have the problem with being in the sidecar for sustainability because companies are not created to make sustainability. In practice, what we see in our studies in Bangladesh, in the garment industry, is then that we have a decoupling problem. We have a buyer and a supplier. The buyer has a procurement unit requesting price, quality, and delivery from the supplier. They have close contact with the production and sales people in the supplier. And then we have a CSR line requiring compliance with a code of conduct and a compliance unit. And they are then responding to these. But there are weak links. So the supplier knows that the strong part is procurement and the weak part is CSR, and that's put to the sideline or decoupled in practice. Looking at regulation of work environment, we had originally a command control system. You still partly have that in Bangladesh because building on old British regulatory principles. In most countries, and also where you're moving with recent changes in the legislation, is more reflexive, focusing on the employer obligation to assess all risk and protect workers from these risks, whether they're independent rules or not. And we are having a lot of international regulation pushing towards that. We have EU regulation, we have UN guiding principles, we have certifications, and we have multi-stakeholder agreements and standards. We know them very well, particularly from the garment industry. The problem is that we build too much on certificates and audits, where we use code of conduct, and then we have multi-stakeholder initiatives to assess code of conduct. But the problem is that audits do not really catch and rectify the real problems. We saw that with Rana Plaza. It's still the same in our new research. We found the same problems, that suppliers often try to hide problems, and buyers, they just use to say, yeah, we have a certificate, so we have done what we can, and audits do not provide incentive to improve conditions. Incentives, they work much better if they are together in this relational governance model I presented before. And briefly, the environment, we can say that up until 50, 40 years ago, it was largely not regulated. But then the main principle compared to safety and health and work environment is that in the environment, we discharge something to water or to air or to soil, and we need a permission for that. And we regulate through permissions and threshold limit values. But with the sustainability agenda, it gets much more complex because it's also a question of resource consumption. That's the climate problem. its interaction with nature, and a lot of unintentional side effects we haven't been aware about before. We have regulation, national and international. If we take Denmark as an example, we have an environmental law, but then we have a large number of other laws influencing the environment in agriculture, municipal planning, drinking water, waste management, preservation legislation, and more could be listed. EU is pushing forward for regulation. They have strong requirements for water. They have CO2 quotas. They have a long list of similar things, which I haven't put on here. EU Green Deal with ESG reporting, among others. And then we have the international agreements, Paris about climate. We have agreement about the ozone breakdown, which is the most successful we have done so far. And then we have many standards, including ISO 14001, and then many of the same multi-stakeholder agreements, which have during the years included environment. So I will just finish then with pointing towards a few suggestions for engineering teaching. I could see in the former presentations the focus on problem-based learning, which we are also using at the University of Southern Denmark. And what I would point to is that for all engineers, we need to integrate sustainability in the normal engineering courses, where we often consider and calculate on cost and efficiency and function. We need then to include sustainability, for instance, material consumption, as the former speaker pointed out. And then we also need to have cross-disciplinary basic courses on sustainability, including supply chain sustainability, so that if you are developing a certain product, if you are programming something, you are considering who's going to do that and which kind of exchanges will be relevant in this case. Then, particularly for production and supply chain engineers, we need to establish sustainability as a parameter on the same level as cost, quality, and delivery, so that we calculate on that as well. And there are now many methods for both qualitative and quantitative assessments. Then we need to teach them specific courses on environment, climate, safety and health, and human rights, so that they know what is the content, what's the topic about. And we need to also focus on the relational governance part of supply chain management, which is often neglected. And then, not least, faculty need to upgrade their knowledge on and qualifications on sustainability and develop research integrated with sustainability. We cannot teach students if the faculty is not sufficiently qualified, if the faculty is not sufficiently committed to sustainability. And then just an example of a cross-discipline course we are running for engineering students at SDU. We use problem-based learning, where groups, they get each a specific large company with a lot of information on the internet, and then they have to analyze that company, and we use the analysis for the exam later on. And they need to use then what we have in classes in the analysis, and just to mention, we are teaching work environment, we are teaching environment, we are teaching how to make double materiality and gap analysis, So double materiality is this, that you're looking at your company, how are we influencing the environment outside our stakeholders, and how are our stakeholders influencing us. We are looking at circular economy. We are looking at certificates and audits, life cycle assessment as presented before, and then how to make change management and action plans. So that's my presentations. I realize you may be too tight for questions, but anyway, thanks for your attention and thanks for the invitation for this presentation.
Okay, thank you very much, Professor Peter Hasle. I think for a very excellent presentation, giving the comprehensive overview on sustainable supply chain management, and also your recommendation for engineering curriculum as well as staff development and research. I think it's very, very important. If the organizer permit, can we take maybe one question? Do we have time?
Yes, Prof. You can.
Yeah, okay. Any one question from the floor?
Can I ask a question if it's allowed?
Oh, please. Yeah.
So first of all, Professor Hasle, you're from Denmark, and as we know, you've got Maersk Line, which is by far the biggest shipping line in the world. And if you've seen the carbon dioxide data, they've actually had a significant reduction in carbon emissions by 40%. If you ask them why they did that, they said they're going to take care of sustainability and the environment. But if you look at the facts, they did it because of money. They saved a lot of money. They made their product more competitive, and they basically said money. So how do you ensure that you can economically incentivize companies and buyers and people and the general public rather than regulations? And number two question would be, we can all agree that Europe and European Union in general has far higher and far stricter regulations when it comes to supply chain, the environment, and the labor. But then you look at China, they don't care about sustainability. They care about growth, and growth. And you, of course, mentioned President Donald Trump. He just relaxed a lot of regulation when it came to environment, labor, and, for example, fracking. And what we've seen that in many ways that I can argue that these sort of regulations have hampered European industry and European growth in many ways. So the way I see it, if in 20 years' time, Europe gets even lesser and lesser part of the world economy and world industry, it wouldn't really matter if Europe in general goes net zero or sustainability, it will maybe matter 10%, but China, Africa, India, and in many ways America, significantly bigger part. So how do you ensure that you do not stifle European growth in European industries while ensuring that Europe plays a big part and generally the world becomes more sustainable? How do you compete with China in that regard? Thank you.
Okay, Professor.
Yeah,
please.
yeah. I can try to answer some of it, starting with Maersk and their policy, without being an expert on how Maersk is operating. I think that it's worth mentioning that they see sustainability as integrating in making a competitive operations. And part of that is that some of the large multinationals, they are actually asking them to show that they are reducing their climate, or they are reducing their climate impact. So they are meeting it from their customers, and then they are looking for solutions, and they are heavily involved in then changing into, for instance, methanol as a new power source, and they are supporting then that you can make production of methanols from green electricity from windmills and solar panels. So I think it's an example of what I'm very much, my line of thinking is, it's the integration question, and we need to work with avoiding decoupling of sustainability and integrate so that we have 4 parameters: sustainability along with price, quality and delivery. Then for the China question, I agree that is very, very problematic in many ways, but we shouldn't overlook that China has actually invested and also now operating more green energy consumption than the rest of the world. So they are actually setting up solar panels, they are setting up windmills in a speed that is larger than the rest of the world. So they are doing some things, but it's also very difficult to control them. I'm involved now in a project where we are studying sustainable battery cell production, and that is again 75% China. And we are getting nice reports about how they are complying with everything. And when we look into it, a lot of it we cannot trust. So they are writing, and it's so difficult to control what's actually going on in China. So they have relations to forced labor, to war minerals from Congo and other things, and a lot of it they are hiding in nice words in their sustainability reports. So there are some pros and cons with China, but not all of it is negative. That's, I think we have to lean to that. I think that's what I could do now. Thanks.
Okay, thank you very much. I think due to time limitation, the participants are encouraged to maybe send an email or a message to Professor Hasle if you have any more queries or for further collaboration. So with that, I think as a chairman of this session, I would like to thank all the 4 presenters, Professor MD Raisuddin Khan from IIUM Malaysia, Professor Salekul Islam from North South University Bangladesh, Mr. Sakib Hossain Khan from University of Portsmouth, UK, and Professor Peter Hasle from SDU, Denmark. Thank you very much. So I think I will end this session and pass back to the coordinator, Mr. Rajesh Banik. Please.
Thank you. Thank you so much to our session chair and all the valuable present for the presentation and their contribution to the session. It has been truly a great session and a great presentation for us all. My special gratitude to Professor Dr. Ahmad, Faris bin Ismail for chairing this session and attending this symposium. Now, as is the end of the technical session 1, we would like to go for a lunch break. Our technical session 2 will begin at Bangladesh time 2:30 p.m. and will be coordinated by my classmate and my good friend, Anand Jahan Chaudhary. Thank you very much.